Alright, let's look at a possible problem you may run into with your gauges. And this could be any of the gauges. It's the routine here that I'm going over. Right now I've got the key turned on. Vehicle is not running. I'm not going to start it up because I've got some wires out there laying across the engine. So I'm not going to start it up because I haven't cleared those off. But key is on. Right now my temperature gauge says it's reading cold, and this could be a real problem that you get coming in with a vehicle. Customer's been driving the car, should be operating temperature, but the gauge still says I'm all the way down here at cold. Yeah, it could be a thermostat. No, that's not going to be a thermostat. I've driven the car far enough. It should be up at operating temperature now. If it was a thermostat, the gauge will be up a little bit. Now this particular car, we've got a code in it, but we're not going to concentrate on the code. Don't live by codes. Even that, if I went in and checked the code, it's going to tell me that the coolant sensor voltage is high. And now I still have to diagnose the code. So my customer says they've been driving the car, they're not getting any heat maybe out of the, or they're getting heat out of the vents, but their temperature gauge is reading cold. It could be the other way, it's reading full hot. Let's see what could happen. So first thing I'm going to do is I'm going to get out my trusty scan tool, and I want to read what is going on. So I want to be able to read the data and on this, and if I go down here, I'm going to put the one we're looking at right up at the very top. Data list at the top says coolant temperature in Celsius, and if you look, it says it's a negative 40 degrees. If you can see that, it's trying to get it focused a little bit too close, but it says negative 40 degrees. You can see the negative sign in front of it, and you can tell there's a number there. That's downright cold. I'm in a t-shirt. It is not negative 40 degrees out here. So I know that's incorrect. Now I could even look down here farther. If I go up one, it tells me the intake air temperature sensor is at 38 degrees Celsius, and the engine is at negative 40 degrees. That would be a 80 degrees Celsius difference. 80 degrees Celsius, about 160 degree difference between the two. I don't think that's right. I don't think the air is going to be that much hotter than the temperature of the engine itself. That's not going to happen. So we know we've got a problem. So first thing I'm going to do, my customer said the gauge always read cold. It never moves. Yeah, I've got a code in here for the coolant sensor, but what I want to do is verify the reading. Do I have a good reading? In this case, negative 40 degrees does not make sense. That is a magic number. I'll tell you about it in a minute. So it doesn't make sense because I'm wearing a t-shirt and this engine's been running. There's no way, even if it was negative 50 degrees outside, this engine's been running for a while, it should have warmed up more than 10 degrees. So we're going to take a look and see what's going on with this. So first thing we're going to do is go out here to the sensor, and we're going to use what's called create the opposite problem. So one of the first things I want to do, if it's dark out and I want to create the opposite problem, I want to turn the lights on so I can see. So can I create the opposite problem? That's basically what you're doing when you check a light bulb. Well, the headlights aren't on. Customer says they don't work, they're not on. Well, turn them on. Turn them on. If they come on, I created the opposite problem. I don't have a problem. So what we're going to do is I'm going to reach down here and unplug this sensor. It's down here in this hole. So if I reach down here and I get it unplugged, I'm going to fish it up here where we can do something with it. So I can't deal with it down in that hole. So we'll get it up here where we can see it. So it's 2 connectors. Now I've got a couple of choices. There's a couple of things I could do. Remember the other sensor that I had? I could use it as a diagnostic tool if I want to, but I may not have sensors for everything. So let's do the standard diagnostics, which is called create the opposite problem. So this will sit here for just a second. Watch what I'm going to do. I'm going to take a very small needle. Now, you should never front probe a connector. Put my technician hat back on. You can front probe a connector, but you must know without a shadow of a doubt that whatever you are putting in here is smaller. Don't try to put something in this terminal that is bigger than the original terminal. It'll spread it. So I know this is smaller. Matter of fact, if you watch, I can put it in there and it will fall out. There's nothing holding it in there. I almost have to hold it in there to get it to stay. So I'm going to touch the one terminal with it, and then I'm going to put another one in. And if you notice, the wire doesn't even bend. It slides in and it's falling out. So I'm going to switch sides because this one has a little bit of a bend in it. Maybe that'll help. And I've kind of got to get them in a bind to stay there. Now that's a special adapter tool. We'll go over that in engine performance class when you have me for that. I discussed these terminals and one just fell out before we could even test it. So let's make sure this thing's going to stay in there. Alright, so we're going to leave that alone. Now, if the temperature was really, really low, if my temperature was really low, think of the type sensor we have. Negative thermal coefficient sensor. So if the temperature was really low, that would mean that the resistance should be really, really high, right? Temperature goes down, resistance goes up. So I've unplugged the connector, and if I'm reading -40, that should mean I have really high resistance. So what if I create really low resistance? Hence the shorted connector. That should be really low resistance, right? So we've created really low resistance, and now let's look at the scan tool and see what we got. And if I pull this up so you can see it right there in the middle, I'm going to try to shield the glare of the sun. Engine coolant temperature 150 degrees Celsius. I know it's a little bit blurry. That's this camera. Sorry about that. Hopefully it looks better on the big screen. But 150 degrees Celsius, remember 100 degrees Celsius is 212 degrees. So if 100 is 212, 150 is a whole lot higher than that. That's actually about 180 degrees Fahrenheit. But let me just point out something. Look at my gauge. My gauge is still reading cold. The reason it's still reading cold is the computer knows the temperature did not change that fast. So I'm just going to try something because this works on some vehicles. On some vehicles I can turn the key off, wait a minute, turn the key back on, and the gauge may react. In this case it is not. That's not bothering me because I have a scan tool here and I can read the sensor itself. So I can still read my sensor and see what it actually is reading. And we started out with a -40. I created the opposite problem. that I had. And if I scroll this up here and put that at the top, and you will see now, just like I said, coolant temperature is now at 150 degrees Celsius, which is about 280 degrees Fahrenheit. We've created the opposite problem. It was reading really, really cold. Now it's reading really, really hot. Now this tells me two things. One, my ECM sees it and recognizes it. So I know without a shadow of a doubt my problem's not in the ECM. It also tells me that the wiring from the connector all the way through the harness to the ECM is good. Because if it wasn't, creating the opposite effect would not have changed my reading. So that tells me the wiring, both wires have to be good all the way back to the ECM, and the ECM is good. Now, pause a second. It doesn't mean, or in this case, it doesn't mean that the sensor is bad yet. What I should do is I can do one of two things. I can either go down with my leads down in here and measure the resistance of my sensor, making sure that I actually do connect the terminals, or the reason I even have this one to begin with is I can use this as a tester. Because if somebody else has been in here and front probed this connector and spread the terminals, they might not be touching. That would create an open circuit, hence negative 40 degrees. Very, very high resistance. So what I could do, if I